Hello, student. Here is one of the homework number 6 problem. I received a couple of the comments regarding for this problem and how we can solve it. So here is the quick solution for this problem. So what we have in this problem here, we have two wires. Let's bring the. So we have two wires and both the wires have 10 ohms as a current, and they are listed as 10 centimeters, one above the other. So maybe in your problem in master physics, different number, but the same idea. So the first one, what we have is 10 centimeter above. So what are you asking to find the magnetic field at the half point? So here, basically, I have R1 equal R2 equal 5 centimeter. So I'm looking for the magnetic field at 5 centimeters away from both wires. Now, since we have two wires here and they have put in the perpendiculars, so we need to find the directions. Again, the magnetic field is as the vector. So the total magnetic field by two wires, that's the total magnetic field, P total. It will be equal P1, or let's call it V horizontal, plus magnetic field come from the vertical wire. But this is additions here. It is vector additions, not just algebraic additions. So the first step, I need to identify where is my component. So to observe the point P, so it's in the middle. So let's assume this point here. And our x's or our x and y, here is the x and here is the y component. Now, based on the x, I need to identify my magnetic field from both wire. So this one is the horizontal wire, and this one I want to call it a vertical wire. So let's find using the right-hand rules, where is the magnetic field comes from the horizontal one. If you put your right hand toward the current, or your thumb toward the current, and your curl fingers point to the magnetic field, you will find the magnetic field will be point down here. That's the only component. So let's call it, this one's B from the horizontal and in Y direction to be accurate. Let's do the same thing for the second wire or the vertical wire. I put my thumb pointed to the current, pointed down, and look at my magnetic field will be point toward this directions. So let's call it, here's the P vertical, but this component in X direction. So basically what we have here, if you wanna write it down in the good scale, I have here is the P in Y directions, and here is the P in X directions. Here is the B comes from the vertical in the X direction, positive X, and here is the magnetic field comes from the or the vertical wires. Let's call it V horizontal Y. So now what we have here, so we have to write down our magnetic field component. Here is the P total. It will be, I don't have any component in, so if you want to be accurate, B vertical in Y component in Y direction, 0. Similarly for the B from the horizontal wire, but in X directions equal 0. So the only component I have X and Y for vertical and horizontal. So here it should be B vertical and X plus P comes from the horizontal in Y direction. Again, this is one not algebraic. It is vector additions. What about the formula for B? Here's the formula for B. Mu dot times I times 2 by R. I have my R's right now. Let's call this one is the R. I have one single value of the R. I have my current. I can find my B. So now the only thing I have two components. If you go back for the vector drawing here, and we try to find the magnetic field component based on that one, I have X component and Y component. The magnetic or the addition for those vector, you remember guys, the head and tail rule. So I can grab my V vector X in that directions. Here is the my B total I'm talking about. This is my B total in that case. So it's the angle or the directions. It is 45 with the clockwise along the positive X. That's the direction. About the magnitude, I have to find the magnitude for this line, the Vx square plus V Hy squared. So that's what we end up with the B as a magnitude, B total. It can a root square of my B vertical X square plus B horizontal Y square. So what the value for both B's, I have R equal R, current equal current. So basically what I have those two components, they are equal. So if you want to type it as a formula, here is the formula that you gonna write. Mu I 2 by R. And this one square plus the same quantity, mu I 2 by R, the same value for the R. This one square. So basically what you end up, this one here is the square 2 times mu I divided by 2 by R. You have all the value that you need, square 2. Mu, it is 1.26 power to the minus 6 Tesla meter divided by amperes divided by 2 by R, it's 0.05 meters times 10 amps. And this number will be 5.7 power to the minus 5 Tesla. Basically, that's it. And the direction for this one should be 45 below the X or the clockwise positive X. That's the only thing. Again, guys, when we find the magnetic field or total magnetic field is additions, but you keep in your mind that additions is vector additions. I think that's it. So that's the problem. And thank you so much.